Right, so today, obviously we've been doing statistics, and this is saying geometric terms and definitions, right? So what does that probably tell you? Probably tells you we're heading into geometry, so we're leaving the statistics behind. We have a test next week, and that we're going into geometry, which is the fun part of the course, okay? So those of you, unless you're just not doing the work on this, then your grades should be pretty good for the rest of the year. But it's up to you guys, okay? And how much work you're going to put into it. So, as you can see, when I say terms and definitions, this is not going to be a real interactive class and getting on the computers, things like that today. It's going to be, we've got to get some definitions down, lay a foundation, so that, because these definitions in geometry are a huge, important piece. All right? So, and we're going to actually come join the group up front. Okay? So here's our essential question. It says describe, I don't know what happened there, it's supposed to have been bigger. It says describe the difference between a postulate theorem and a proof. We're joining a group if you're part of the class. All right, are we done with that? On the other end, anybody on the other end should be checking off. You can give me a check mark when they're done. We're going to have to kind of go through that process on the other end. Good? All right. So, when you start with geometry, geometry is all about it's all about the vocabulary and definitions and all kind of the rules and that kind of stuff. So our first definition that we've got here is a point. Okay, and I kind of did this so that we have a box, and the box has for every single word. The box has 4 parts. One part is definition. One part is going to be for characteristics, so things we need to know about that word. Then you have an example and a non-example. Okay? So if everybody right now give me an example of what a point looks like, right? And something that's an example of something that's a geometry kind of something that's not a point. And I do really want to see this four-part piece of it because that really helps you understand the words, and there's more to the words, knowing the word than just knowing its definition for geometry, for some of the stuff we're doing. Okay. Yeah, for this one, there's not a whole lot of stuff still in here. But some of the others, there's going to be quite a bit of stuff, so make sure you do I'm asking you to use actually use an example, an example, and that's it for this. I'm going to cover the piece. Okay. But the rest will kind of go through box by box so you can kind of get a feel for how big this one can be. All right? And if it's easier for you to do definitions of characteristics here, then example 1, example of the farm is long. I'll help you through there. Okay. The other day you give me an example of a point. Just copy this down and put an example of a point. Several people, when they did this, they just did this. They said, I've got a point. Are they right? Yeah, so don't sit and wait for me. You guys could have put that. A lot of you are kind of sitting waiting for me to put that on there. You guys could have put that on there. You knew that, right? The one thing about geometry is that we always label our points. So we're going to label it with a capital A. And so that point, we'd call that point A. Could we have labeled it with a different name? Yeah, we could have used any letter of the alphabet. We usually use the capital letter to label the point. Okay? What would be a non-example?
A line on the shape.
A line, yeah. Okay. So it'd be, is there another example or non-example? Some shapes, okay. Example things like that. Now, if you guys have an intake, make sure you get an intake from me. If not, we're going to have to create one. I'm going to have to get some more paper to create it. Okay, so definition of points. Now, points in geometry is kind of something we kind of intuitively know. There's not a whole lot of definition to this, but what we have is there's a location space with no length, width, or depth. And it's just kind of an intuitive thing. Okay, and characteristics are just things we need to know about that definition that might help us recognize it, or just other information. And one of the things we need to know is that it's something we call an undefined term, because it's just going to be true to know. So if you give me a definition that exactly explains with pictures, that will not. And so mathematically we call it an undefined term. It's one of three basic terms that we consider to become undefined. And that everything else in the geometry is built on. Okay? And then it really has a type. Okay. So you guys kind of get the feel for how this box works there. Okay? Our Freyer model here. You've probably seen that in some of your other classes. So we've got the word point. After we have a point, then we can build a line. Because a line, by definition, uses points. We can't have a line without having points. So here's a couple different versions of a definition for line. First one, it says a collection of points arranged in a straight path. The next one says it's probably a little bit more accurate because of something it has in there the first one doesn't. It says a straight set of points that extends off to infinity in two directions. The probably more accurate one is that part has the infinity. Okay, so let's look at some of the characteristics that come out either from the definition or things that we need to know. Again, this is one of our three undefined terms. The line has to be continuous. That means there's no breaks as it goes along. Kind of goes along with going into infinity, right? If it didn't continue on and on and on and wasn't continuous, it wouldn't go to infinity. Yeah, no gaps or spaces, that's what that continuous means. It has infinite length. That means the line goes on and on and on forever and doesn't stop. Okay? It doesn't have width or height. And we'll talk about that last one in just a second. Sorry, I'm trying to get this to... All right, so let's look at our example of what a line looks like. So what do you notice about this line? Where I draw a picture of the line, based on what we know about the infinity part. What do you notice? Yeah, we know it extends in both directions because it has the arrows on both sides. That tells me it's going on and on forever, just like when we graphed, right? We had to put the arrows on the ends of the axes because we know to show it continued on, even though we didn't have, we only had a small picture of what was there. It could have been a lot bigger picture. We just didn't put that there, put the things there. All right. So now, when you're talking about geometry, one of the things we do is we give our lines we give things names, just like we gave the points the name A. we can name our lines. And so what we usually do is we put a point on the line, and we give it a letter name. It could be something other than A, but I chose to call it A. And over here, I'm going to give it a name B. Okay? So I've got 2 points that are on the line, because remember the line's made up of all sorts of points that just kind of, you keep putting as many points in, and if you just did that across your paper, then you'd see that eventually you'd get, if you fill in and make the line. And so I picked 2 of the points there, and I called those points A and B. So to name the line, what I would do is I would say, I'd write AB and put a little line like with both arrows on both sides. Can you guys kind of see the arrows on both sides of that? Okay. There's arrows here and here, or I can call it BA. It doesn't make a difference which one you start with. It's still representing the same line. Okay? So when we name the line, that's how we name it. If you're going to write it on your paper or write it down for geometry to describe it to somebody else. Okay? And that's really, really important. It's important to know also that the order doesn't matter for those letters with the line. I believe that's what I wrote down here. Yep. Basically what's behind that, it says the line is named by AB or BA. And also, sometimes when we're talking about the letters, remember I said you use capital letters to label the points? Because sometimes we use the small letters, such as the letter M, to label the line. Okay? Mm-hmm. So, what would be some non-examples? Can you guys come up with some non-examples? Go ahead and try to fill something in. Put something, a couple of non-examples in your, based on what we know a straight line has to be. What would be a non-example? Okay. All right, so here's some non-examples that I came up with. Why is that one a non-example? Right, it only goes one direction, and we'll have a name for that in a couple minutes, okay, for something that only goes one direction. And some of you are already thinking of the name of it, okay? What about that one? Okay, it's just so far it doesn't go beyond that, does it? Okay, I know that because there's no arrows. Some of you put that down. Do you have examples like that? Why are those not examples? Come out straight, right? Okay. Excellent. Okay, let's look at another one. Collinear. Anybody recommending a word within that word? Linear, okay? It needs to be a straight line. So we consider points to be collinear. We want points to be collinear when they actually are on a line. They form a line. Okay. So let's look at the definition. And you guys basically figure out the definition without having to have me tell you. Linear, so they had to get a line, and co would mean they had to all be together, right? They had to be in the same. Okay? I think that you can add some characteristics there yourself for this. Can you guys come up with your own example? Let's just do one together. I have a straight line. We're going to pretend that's nice and straight. Then I could have point A, point C, and point B, like that. Okay? And those are considered to be collinear because they're on the same line. What would a non-example be?
That's not linear.
Okay, maybe a line that's not linear, but if we're talking linear still, what would be a non-example? I do this. And I had A, and I had B over here. Where would C go if they're not collinear? Yeah, C might go right here, right? So those three are not collinear because they're not all on the line. Okay, I want you guys to fill in some of the characteristics on that. Such as, like, they have to be, you're talking about points, right? And they have to be on the same line. Those are the big things with that one. What if they're non-collinear? We know collinear. What is non-collinear? What do you think? If collinears are on the same line, non means not, right? So if they're non-collinear, they're not on the same line. So that becomes like our non-example from the previous one, wouldn't it? Okay. So can you guys fill in actually examples and non-examples on your own with this? Okay, we kind of got this one done. Let's move on. All right. Do I need to, you guys want me to put an example up here to check what you put down? Or you think you've come good with it? Basically, we just reverse what you had last time. For the collinear ones, then you've got your example and non-example, okay? All right, line segment. Anybody know what a line segment is? A line is things that run on forever, so what a line segment you say something is. A portion of the line, excellent. So now we're at the point, because we have two of our basic undefined terms, and we're using those basic undefined terms to define other terms. We have the collinear, the non-collinear, those are all defined by using points, right? And lines. And then we've got line segment, which is also defined by the term line. So just as Aaron said, is a part of a line that consists of two endpoints and all the points in between. It's a portion of the line. You can write that. You can add that to this also. That helps you understand and remember it. It's not just a copy of my words. I'm going to give you some definite words and some things that you guys should know things that you can help you. So I believe it's a portion of the line. That would be great to add to that. And you could put it actually right down here under characteristics. Okay, so what else? Basically, looking at the definition I provided you, what else do we need to know about that? There's a part of the line, so there's a portion of the line that consists of what? What do we need to have to identify an endpoint? Or a what? Endpoints. Okay? What else does it have? It's all the points in between. So remember, what's our definition of a line? All the points that go together to make it solid, right? Okay. So if it has endpoints, then it's going to look like this. And we're going to pretend again that that's a straight line. Then we can label it again. And remember that for our line, how do we name our line, the actual line? Remember, a line's different than a line segment. The line goes on forever. The line segment is a part of that line. It has a starting and stopping point. So how do we label the line? How do we name it? We said it was, what, A, B, and then above it we put a little line above it, right? With the end arrows on it. So what do you think we're going to do for a line segment? Yeah. Okay, or you could just do a line, okay? So it's exactly right, because it represents exactly it's telling you exactly what we're talking about. So you could say AB, and just put a line like that. There's no arrows on the end. Or you could do BA, doesn't make a difference. Okay? Or you can use a little letter. All right? So when you see the thing without the arrows, like you do have here, so you see it without the arrows like that, that tells you it's a line segment. When you see it with the arrows like that, it tells you it's a line that goes on forever. So it's important that what that symbol is that's there is really important, so you know what you're talking about, what shape you're talking about, or what thing in geometry you're talking about. Okay? If it's a point, it just has one letter. If it's a line or a line segment, it's going to have two letters. And in this case, it doesn't make a difference. The order does it. Okay? So what might be a non-example?
Straight line.
Just a straight line, a line by the definition of geometry, right? Okay? So something that's going to go on for ever in one direction or the other, both directions, right? Another example would be if it's just going in one direction with an arrow, right? Or it could go the other direction with an arrow. If it's, you guys are drawing yours a lot straighter than mine, I'm sure. But if it's a curvy line, would that work for a line segment? Mm-mm. Okay. So if I go like this, and I have a stopping point and two stopping points, it's still not a line segment because it's not straight. Okay? Important to know that if we're talking line or line segment, it's always straight. Okay? So ready to go to the next one? So now we're going to go back to our third undefined term, which is plane. And it doesn't mean the thing you write in up in the air. Okay? I know. That would have been more fun, wouldn't it? Okay? So a definition of a plane is a flat surface with infinite length and width but no thickness. So it's kind of like looking at the top of your desk, and pretend the top of your desk would be a portion of a plane. If you think about taking your desk and continuing on and on and on forever in each direction, okay, in each direction is the way it's going, then that would be a plane. Okay, the door would be a plane if we considered that it went further up, further out, and continued on. Okay, or one of our whiteboards could be considered a plane because it continues on if it continued on in each direction, right? Okay, but it has length and width, so it's two-dimensional basically. Our point and our lines only had one of those dimensions. It had like length, right? The point had nothing, right? There's no dimensions for the point. The line was one-dimensional because it had length. It had no width or thickness. And now we have a two-dimensional shape that we're kind of describing a plane. Okay? So there's a lot of characteristics that you need to know about that. It's an undefined term, like I said earlier. There's some information about how we decide whether it's actually a plane or not. It says any three collinear points determine one and only one plane. So remember any three non-collinear. Did I say collinear? I just said non-collinear. So what does that mean? If it says they're non-collinear, what does that tell us? That they're not in a straight line. Yep. Okay. So any three non-collinear points determine one and only one plane. And the plane includes all the points that lie on that flat surface. So remember we had all the points to make the line. Now we have even more points because it's all the points that make up that flat surface, that fill it up, that fill it in. Okay? Kind of goes along with the idea of area, doesn't it? Length and width and area. It also extends forever in all directions. just like the line extends forever in the two directions it's pointing. Okay. Another way to think about it is like taking the top of your desk or the board and just kind of continue growing it, expanding, 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 expanding forever and ever, right? Okay. And let me do this so we can get rid of that. So you identify a plane by naming the three non-collinear points. Okay, so you identify a plane by naming the three non-collinear points in the plane. Now, when we draw a picture of something to represent the plane, and sorry, I didn't do that, we usually draw some sort of shape and pretend we have to imagine in our heads that it's going to go on, get bigger and bigger and bigger. Okay, so here's an example of something that might be a plane. Usually, we kind of think about planes as more rectangular. Okay, and then you'd have some points in that plane. Okay, and they're non-collinear, so they don't make a straight line. And we could label A, B, C. So we would call this plane, let's call it plane ABC. So we're kind of learning all this language, these words, because we're going to start speaking in the language of geometry here pretty soon, and we need to know what words to use to speak the geometry language. Kind of like learning Spanish, you have to learn new words. I mean, what we know already first, right? If we say cat in Spanish, it's what? Gato. It means the same thing, right? We had to learn a new word for it. Okay. So sometimes we have to learn new vocabulary, kind of a new language, so we can speak about the mathematics of things. Okay? So a non-example would be if they were in a straight line, right? You could still have this rectangle around, but would this rectangle necessarily be a plane if these are in a straight line? Okay. And again, you guys can do a lot better drawing yours than I can with this, so just to kind of pretend like mine are perfectly rectangular and so on. Maybe yours better than mine. Okay. That doesn't work because they are collinear and they have to be non-collinear. Okay? And that was blocking, so anybody needs to finish that up. You guys okay with that? All right. What do you think coplanar would be? Is it coplanar? There are points that lie in the same plane. Now I'll let you do that and fill in the examples, non-examples, and so on. I think you can figure that out based on the definition, right? So, using our basic terms that we talked about, what of those words can we identify up here? We talked about points, lines, planes, collinear, non-collinear, line segments. Which ones can we identify? Planes and lines. So give me the name of a point, you see. Point A. Okay? Everybody see that point? So we can call, even though this might be helping name the line, we can also look at it and say that's point A, can't we? What about this point right here? Why is that point important?
Because it's connecting the two ends together.
It's not connecting them, it's where they what? It's where they intersect. Okay, it's showing the point of intersection. Okay? So that's important. So we use those terms when we're looking at different things, and sometimes all at the same time, because what's the name of one of the lines? How can we name one of the lines there? Leslie, what do you think? Let's look at this line right here. How could you name that? How many letters do we need to know so we can name the line? Actually, we don't need 3. We only need 2. Okay, so can you tell me 2 names of letters there? A and B. So I could write, so I'm going to name the line. I write A, B. You remember, put that little line thing right, symbol above it, right? Could you call it AX? Would that work? Because X is on the line, isn't it? Could you have called it XA? Yeah, because remember we can reverse the order, right? So we've called it BA. Okay. As long as we put that little line symbol above it to say this is a line, right? It's continuing on forever. All right. What about the next side of this over here? What are these? Here's somebody saying it. Who's being timid over there? They're correct. What is it called? Go ahead, Wyatt.
Planes.
They're called planes. Notice how they label the planes. I didn't tell you that before, but they use like a script letter, capital letter. So this green one would be plane M. The other way you could do it is with the letters too. It's another way to do it. And this would be plane N. Okay? So you've got 2 planes. What else do you see in this picture? See a line. Where is that line? It's not in between each plane. It looks like it is, but it's not quite. What's happening with those 2 planes? They're intersecting, so what is the line showing us? Yep, and notice that this time they used the small letter S to label the line because there's no points on there, okay? Here's the other way to do that. So, what I covered up here, it says line AB intersects line CD at point X. See how they described that picture? And using the geometry symbols and stuff like we've been talking about to describe that. And you're going to be actually doing some of that when you start doing geometry. And we actually dig into some of the work. Okay? And this one, they said planes M and N intersect at line S. Okay? So again, using that vocabulary, the symbols, and so on. Okay? Last couple things here. I know it says there's like 19 slides, but I had added some slides. I forgot to take them off at the end when I was done. Okay? So array, the word ray. A ray is a part of a line that begins from an endpoint and goes indefinitely in one direction. A line goes in both directions, right? A segment, start and stop, right? A ray has a starting point and goes in one direction. Okay, so if we wanted to put some characteristics down based on what we saw there. That was a starting point, right? What else?
Linear. Linear. Linear.
It's linear, yeah. It's straight, right? I don't want to put the word line on there because it's not a line, is it? But it is straight. Okay, what else? Yeah, it goes one direction infinitely, right? Okay. So remember that one, those things where I had the arrow on one end? Now we know what they're called, right? They're called rays. So let's draw an example. So we have a starting point, an arrow. You have the starting point down here, and coming back this way. It could go in, it doesn't have to be horizontal, it could go at an angle, okay? It does also get named. If this is A, and this is B, we could say that this is AB, and it's a little ray symbol on top. Now, one thing that we need to make sure we add to our characteristics or make a note in our example is that when we name it, starting point has to come first here. Remember the line in the line segment is reverse the order, right? But for a ray, we have to start with the starting point. So A is the starting point, isn't it? And B is the point it goes through. So we have to start with the A and go to the B. For the one down below it, I'm going to change colors so we can connect it together here. We can make connections between them. This one is the starting point here, and this is the B, and the A is down here. Then this one would be, how do we do this one? The one above it is AB, and it has to be AB because A is the starting point. The one below it has to be BA, because B is my starting point. And this one goes with this. I'm going to circle them so you guys know that. And the one above it and that one, this one goes with that one. Okay? So for array, the starting point matters. And when you name it. Okay, now I can note that down. I didn't type it down or anything anywhere, but that doesn't mean you don't not write that down. Okay? Because it's not up there doesn't mean you don't write it down. It's an important idea. Okay? And I was hoping we'd be done early. So you can get a non-example and you can write it incorrectly and you can do lines and you can do all sorts of stuff. Okay? Last one is angles. Okay? And you guys have seen angles before, but let's get an actual definition for geometry. It says a figure is made by two rays that do not lie on the same line. Actually, they could, but they have the same endpoint. So if I'm drawing a picture of this, you guys have seen this before. If I have a starting point, I have one ray that goes this direction, and I have another one that goes maybe this direction. I've got two rays with the same starting point, and they're not on the same line. Okay? And so the space in here, that's what's called the angle. And you guys have seen this before, right? Okay? So I would eventually guess you guys can kind of figure out the rest of this, right? Finish that up? I know a couple of you need to get out of here. I was hoping to be done earlier. Oh, we didn't get the postulate and other stuff. I'll do extra credit for you guys. Okay? Also, just so you know, there's an extra credit opportunity, another extra credit opportunity. Next Saturday is Pi Day. 314, right? 3.14 is pi, right? But on Friday, so you don't have to come in on Saturday. That's right. Mrs. Giesbrecht is, and I'm going to help her a little bit, is going to do a Pi Day. And it's going to be from 10, with activities, go from 10 to 12. No, 10 to 1. So the hour before, get this, and then an hour after. So you guys can go participate in that and do the activities, and also get some extra credit. Okay? So you're going to need to come to class. You can't skip that class to do that, because we've got some big important stuff. So you'll have the opportunity for this for extra credit. I'll finish this up this afternoon and get it posted. So you'll have the regular recording. If you go back to it, you'll have this from here to the end, which isn't real long, so it may not be a full 10 points because it's not really long. But it's still extra credit points. And then you have an opportunity for extra credit if you come to Pi Day. Okay? And do all the activities. It's Friday. And the official day would be Saturday, but we're not going to make you come in on Saturday. So name tags right up here and the desk right up here. I need to sign off on some of these.